Hello, everyone. I'm Ming-Chi Han, and this is the video explanation for homework 4, question number 1. In this question, we need to find out the probability distribution function of y and the probability density function of y, given that f in terms of f, the probability distribution function of x, and the probability density function of x. We are not explicitly given a probability density function of fx. Instead, we have this curve here, but we do not have any value to it. So for now, we have to set it aside. But we do have y equal to gx equal to their respective value in their respective range. So we can start from here. Then this is the plot. This is the plot for that for what we have here. And if we really need to find out what's for probability density function of y, what the range and the respective values are. And in this case, it's not easy to see from this graph, but if we do a maneuver like this, we get the graph of this is at the horizontal axis becomes y and the vertical axis becomes x. It's now easy to see what ranges we do have. Here, let's start from here. Here we have y equal to -1. There's some x value over here. So we have a circle 1 like that. This part is y smaller than 0, larger than 1. And we have circle 2. This range is y equal to 0, circle 3. There's nothing here, but we do have a y equal to 1 over here, and that's circle 4. Everything else, including this part, which is written, I believe, over here, and this part and this part have nothing. Now we have the range for this. And of course, yeah, we after having this range, we can also have the probability distribution functions ranges is over here. And this, because we the graph we had have nothing over here because it's a density function, but at the distribution function, anything over this would be 0, and anything over beyond there would be 1. There are values over here. So this range is of combine these two because there's value over here, and that we have this range. This are this, and this comes from here. Anything, oh, this, sorry. This is the combination of these two. This is just whatever's left to the not defined value, and this is the right to the largest value defined, and that's it. And yeah, so now we have this for the 5 circles. We can figure out their values respectively. For circle 1, it's just that we have y equal to -1. For this -1 to exist, we have is basically the same thing as x larger than 2, because here. And for that distribution is basically just 1 minus f x2. We have it over here, and 2 is different from than the other 3, 1, 3, 4. So I'll jump to we will skip it and jump back to it after 3 and 4. 3 is relatively easy. It's just y equal to 0. Y equal to 0 has this range, so it's basically just p of x smaller than 1, larger than 0, and that's the function is over here, described as the probability distribution function of x. And for this is the same thing. X smaller than 0, so it's just this part. For circle 2, we have this equation that we used last time in our homework, and we can use that again over in here. This, and in order to use that, we need to figure out what's this line. This line is y equal to 1 minus x. So in terms of x, y is 1 minus, in terms of x, y is 1 minus y. X is 1 minus y. And we plug it in over there. And the g prime x is just -1. We have this value. Now, this for circle 5 is just 0. It's not defined. Now we have the probability distribution, density function, and we can simply draw that. For x at for y at -1, we have this function. It's just the area of this part, and from -1 to 0 of y, we have this function. Because we do not have the exact value of fx, we just have a graph. We can just draw it like this, like it's implied like this, because and for the other parts, it's just like this part. We have the area of this and the area of this, and that's the graph of the probability density function of y. For the distribution function of y is relatively easier after we get this. So this and this are really easy to get because it is defined over here, right? And anything beyond that, beyond this would be 0. Oh, beyond this would be 0. Beyond that would be 1. And for this part, it would be the integration of what we had in over here, and it's also just the probability distribution of y smaller than y, because it's written. You can either use this integration to figure out this part, or it's just derivation from this part. And for this part, it's done here. And for y smaller than 1, larger than 0, it's because we had a spike over here, or a delta impulse signal over here. There's a jump at this location, and it will jump to 1 minus fx of 1, because beyond that there's another jump which will complete that to be equal to 1, and for that is 1 minus fx of 0. And oops. And that is everything that that's needed to solve this question.